grab the chair.
Yeah, sure.
Yeah,
I
just
can
use
do
this.
Okay.
Okay, so we're live. Hi, hello, Nupik. This is our HTM Hackers Hangout. It's sort of our newish format. It's our second or third one of them. So the goal of this meeting is really just to kind of sync and to exchange ideas and see if anybody needs any help or is experiencing any problems or new things. I have a couple of things that I would like to talk about, but other than that, I would just like to open the floor and see if anybody wants to discuss anything in particular. David Ray has been out sick for a while now. He's been really under the weather, so I don't know if he's going to end up joining us. He's the HTM Java lead engineer for us. He works at Cortical.io, so I'm not sure he's going to join in. But other than that, we do have Subutai and team in the office. There's Marcus Lewis on the left there, and Austin Marshall on the right. Looks like Felix has joined us as well, and we have a couple of newcomers we haven't seen. So thanks for joining us. We appreciate you being here. So I'm just going to start with the topics I wanted to talk about, and maybe after we get through that, we can talk about whatever anyone else wants to talk about. So the first thing that I wanted to mention was in Nupik, when you're creating model parameters, I wanted to talk about the temporal implementation setting inside model params. So historically, that has always been CPP, okay, which is and what that means is like not the spatial pooling part of it, but what we used to call the temporal pooling or the temporal sequence, processing or analyzation portion of it. It's basically specifying what algorithm should be used for that part of the HTM setup. So, like I said, historically it has been CPP, which is the old temporal pooling 10x C++ implementation, and that is currently what we would call the production version of the algorithm. We have been working for a long time on the temporal memory algorithm, which is the new hotness, but it's not as performant, I believe, as the old one, and it's not as rigorously tested, I would say, as the new temporal memory one. So there are options now. Instead of CPP for temporal implementation in model parameters, you can use TM_PY, which is the Python implementation of temporal memory, or TM_CPP, which is the C++ implementation of temporal memory, which I believe is pretty much done. Correct me if I'm wrong. I know there was a couple of dangling issues there about whether that was really ready or not. But both of those temporal memory implementations are still kind of new. We wouldn't say that they're production ready. We haven't made them the default in any of our examples. Swarming doesn't try them at all. It always uses the old, more of the temporal pooling algorithm, which I guess is the second or third generation, depending on what Subutai calls it. So that was one thing, and I don't know if you guys in the office want to comment on that at all. It's up to you.
I think that's a pretty good description, what you just said. So the new TM_Pi and TM_CPP are close to, but not quite production ready yet. But people who are experimenting could use that. And that algorithm corresponds much closer to what's in the white paper, so it's much easier to understand and follow through.
Right. I've been using it in all of my new projects. But I haven't gone back and changed any example code to use it. So when it matures to the point where we would consider it to be the production ready, I guess, I would like to go back and update all of our example code bases to use that and run them all and make sure they all work appropriately. So that was one thing.
If anyone has run NAB with it, that would be interesting to do and make sure it works.
That could be another entry in NAB. Hopefully it's very similar. Okay, so that was the one topic that I wanted to talk about. the other is about data aggregation, just because this is something I've been doing a lot of lately. And it didn't quite make sense to me at first, so there's maybe some of you out there it doesn't quite make sense to. So I'd like to explain at least how I understand it at this point. So this all came from me wiring up our office with a bunch of smart things and Internet of Things, sensors. One of them is a smart outlet, and you can plug it into the wall and plug something into it, and it gives you very fast streaming data on power consumption, power usage flowing through that outlet. And so I hooked it up to Vitaly's workstation, of course, and who volunteered to allow me to do this. And I was monitoring how much power usage his workstation was using throughout the day. So obviously I can tell when he comes in, when he takes his breaks, when he goes to lunch, which is amusing. But the thing that tripped me up was when it's not connected, or there's no power usage to the outlet, the sensor itself gives me like an update every 10 seconds or so. It's a 10 seconds or a minute, but a relatively slow rate. And it basically says no power usage, no power usage, no power usage. And also if it's a very constant power usage, like a lamp or something that is not constantly changing, it also is a slower rate of update. But if it's hooked up to his workstation and his computer's plugged into it and he's got the screen on and that thing's going up and down, and I'm getting constant updates, many updates per second. And I sort of expected naively that I could just take that stream, and because if you look at that data over time, there's a daily pattern and there's a weekly pattern, very similar to like the hot gym example. So I assumed I'll just take that raw stream and I'll feed it into NewPick and use the same parameters that I would use in the hot gym example. But it didn't work well at all. And guys in the know in the office quickly said, well, you're not doing any aggregation, so it's not going to work. And so that didn't make sense to me at first, but so it sort of makes sense now, because if you think about the speed at which, or the regularity at which data is fed into your senses is very regular. Like there's no inconsistency for the most part with how often your neurons are firing coming from any of your senses. But this data, this sensor, has a lot of irregularity. There's times when it's not sending many updates at all, and there's times when it's sending a ton of updates. So that sort of has to be made into some type of regular flow, regular stream. So I did put in place an aggregation strategy and say, instead of just allowing the sensor to decide how often it's going to stream data into the HTM, I'm going to do a mean aggregation over time, over certain time periods. So maybe every 10 seconds I'll do a mean aggregation of all the values the sensor's seen and send that in. So every 10 seconds it gets something. And I was much more successful using it that way, because then, since the HTM has something regular coming in, it knows at what scale to identify the patterns. Am I saying that right? Does that make sense to you guys? Okay.
Yeah, it definitely helps if you have more regular sequences in the data.
Yeah, and if you look at the data, you're not losing really anything at all. As far as characteristics of the power usage over time, if you do a mean aggregation over 10 seconds, you're not losing any details that matter. So for the most part, you're cutting down your compute time to the extreme and making everything more efficient, and you're not confusing the HTM as much. So I thought I would share that because I understand that better now, and I'm putting together some aggregation features around InfluxDB now, because I'm storing all this data into InfluxDB, and I'm starting to understand how to pull aggregated data out of that database and stream it directly into HTM. And if you guys want to learn more about that, come to our Bay Area HTM Meetup on the 14th of March in a couple weeks. That's all I want to talk about.
Did you try the new kind of params finder thing on it?
No, I would love to.
Yeah, it's supposed to tell you the aggregation automatically.
Is it still in the research code base?
No, it's being moved over. You might know.
Numenta apps.
It's Numenta apps. Okay.
You talking about the unicorn where it has the brand finder in it? Yeah.
Yeah.
All right, so it shouldn't be in Numenta Apps. It should be in NewFig.
Yeah, and I think they want to do that. I'd said this exact same thing to them. I think it would be generally useful. So I think that's the plan, is to put it into NewFig at some point.
Yeah.
But, I mean, Numenta Apps is open too, so anyone can look at that.
Sure. Yeah, because this is something that's generic enough. I could use it in Riverview, because I've got tools that's pulling data out of Riverview, and so I could find that sweet spot of aggregation period or whatever, and automatically tune for it. So that could be used all over, and in my InfluxDB stuff too.
Did you consider running multiple models at different time intervals?
I'd like to, so I've thought about it, but I haven't. One of the problems that I'm having is because I'm using this HTM in the Cloud project that Jonathan McKenzie worked on, and it's not very scalable. So I hit the wall pretty quickly with that thing. I'll create a few models, I'll pass a few 100,000 rows of data into it, and everything blows up. So I'm working with some scalability issues. So I'm trying to keep my footprint very small at the moment. So anyhow, I'm interested in finding out if anyone else wants to talk about anything. So I would like to open the floor.
I'm curious about the Windows progress. I see a lot of emails go by on the hackers list, but I don't know what our state is there.
Hey, Subotai.
Hey, Richard.
Hey, nice to see you being here.
Yeah, I just arrived late. Sorry about that. It's been a busy month working on some new contract work.
Just coming back from the pubs?
No, it's I'm working with a company on the East Coast this time, so the time difference is a bit easier. The Windows stuff, I've been keeping an eye on it since Christmas, and it's nice to see it and going to see people using it. I've been doing some support on the mailing list to make sure that people can use it properly. And it's nice to see Vitaly trying to tackle the 32-bit version of not just Windows, but also the other ones, the other operating systems. But as far as I'm aware, the way I left it on Christmas, it's all running on AppVeyor, all the integration tests, the swarming. I put in a PR just before Christmas for the NAB, so that runs on Windows. So the 64-bit version people are using.
Yeah, we're using it in the Unicorn Windows 64-bit Windows pipeline.
Because it's only the 32-bit that's really still in progress. Yeah, that's cool.
And Vitaly's kind of tackling, he's hitting the issues the obvious issues of trying to create the 32-bit external support libraries, trying to get those right, to get the static versions of those rather than the dynamic versions.
Yeah.
But he seems to be making some nice progress on that.
That's cool.
And Matt, there's something else that has kind of flown in under the radar. It's not exactly Windows related, but with our work on getting Bamboo set up, we actually have some pipelines that are running that are building a distribution of Python that has NewPick built into it.
Right.
For OS X. So, like, technically, anyone could download that version of Python that has the version of NewPick, like, literally bundled into it. There's no installation necessary. I wonder if there's some value in bringing some more attention to that. And
I think there is, specifically because there have been some people on Windows, on the mailing list, asking questions about how to get it running on Windows, who clearly don't really have much Windows development experience. So this might be a good avenue for them. And all we would really need is a wiki page, right, with some instructions on how to go about it.
Yeah, I mean, the Bamboo instance itself is open. We just need to add some documentation on how to download it, because we have Windows builds and we have OS X builds.
One of the things that we've faced already is as the time goes by, when packages that NewPick depends on, get evolved. One of them, like the wheel package, broke a lot of things recently. So having like a separate distribution like that can help isolate changes going forward.
Yeah, so put that on my to-do list to try and get someone to work on that wiki page. And yeah, that would be useful. Yeah, I've been surprised how many people have been trying to get Nupic running on Windows, to the point where I've explicitly sent an email saying, by the way, we don't quite support Nupic on Windows yet, because I feel like people are expecting it to work on Windows, and we're like, Richard did a ton of work, and thank you very much again for doing that. But we're not quite to the pip install Nupic phase on Windows at this point. And also, Richard, you've been really helpful on the mailing list to get these people up and running, and these guys have gotten up and running with Nupic on Windows for the most part, which is amazing. Awesome.
Would the distribution help out with the homebrew issue on OS X?
Yes. Well, it depends. You could basically have a single downloadable binary, or not binary, but a Python distribution that is separate from the homebrew Python. And yeah, there wouldn't be any sort of conflict between the two.
Yeah, because at the moment on Windows you've got the pip install Nupic that picks everything up if you use in the right Python. We've already seen somebody trying to use it with a 32-bit Python, and it can't find the right distributions for the bindings file.
Right.
They tried a 64 and got it working. They just mailed back tonight and got that working.
So another thing that's happening is
I can talk about it.
Yeah, talk about
so
that.
like one little project I've been doing is Nupic core encoders, and writing encoders in C++ is like one thing. It's it's not that hard of a thing to do. But the more difficult, ambiguous part was how do you fit that into a Nupic network. So that's kind of a work in progress. Probably today I'll have a pull request that actually does that. So so in general, I think this makes it where. So I've only done the scalar encoder, but the rest of them are now basically low-hanging fruit, or will be next week or so. And so that'll be out there. It's now a thing we can just like pull those in, whether it's like us, if people get really interested in doing that kind of thing, it'd just be a place you could dive in. So
yeah, I guess once the structure is in place, and something anyone could add new encoders now.
Yeah,
pretty easily and follow that same structure.
Yeah.
And I mean, theoretically, we could add encoders in different languages, right? When we have this C++ base encoder, we can, if the language bindings exist, we could implement encoders in other languages, right?
Yes, it'll be more. You'll see the precedent. You'll see how like we have these core C++ encoders. We also have these Python ones. We use both. And so the way you do it in another language would be to kind of mirror the strategy. It wouldn't be to like inherit from anything. It would be to mirror the strategy we use with Python.
Would the new encoders have a Swig interface?
Yeah, the plan is yes, but that's not going to be done this weekend or anything like that.
No, sure.
Yeah, and the hope is, I think once, let's say you do the scalar encoder, we can deprecate the Python version of the scalar encoder.
Yeah.
There's no point having two implementations, and then we can slowly get rid of that.
Yeah.
Move everything into the C++.
Yes, and that also, we talked about a little bit. We're not trying to completely mirror every parameter. Like, it's okay that if our encoders written in C++ take a slightly different set of parameters, or have like a different class structure, we're not trying to completely reverse engineer the Python ones. So unless there's pushback on that.
Okay. Any other topics? You got anything on your mind, Felix?
Sure. So I've been reading a lot of papers, I guess, trying to just figure out what to do next to get the best impact. I've actually started playing around with a few data sets to try to work out how the features that are being learned by HTM. Okay, the goal, I think, should be to learn features that are reusable and generic in some way, so that they can be recombined for the novel inputs. And I'm not convinced that HTM is doing that at the moment. So there's topics like decorrelation that come up in the literature, and homeostatic mechanisms. Yeah, I'm still not quite sure what the right strategy is, but I'm looking at actually the MNIST data is one, and there's a data set from Josh Tenenbaum on basically a sort of cognitive data set on attributes of animals. And it's like, was it 80 animals, each with 60 features, something like that. Which reminded me of it's sort of like the, in the spirit of the Fox Eats data, if you can call it data, but larger scale, and you can start to look at how, if you can learn some generic features of types of animals based on, I guess it's called feature induction. Anyway, I'm not able to talk clearly about it because I'm still in the state of working out exactly what the questions are and what direction to go in. So,
is the idea that you'd be able to then do analogies, basically? Like if you learn something about some animals or whatever, you could then transfer that learning some other structure.
Yeah. I think that's what's meant by feature induction. Yeah. So if you observe some features, you can assume another one. And I think in the HTM context, you'd be translating the data matrix into little temporal sequences that ask questions, that make statements. Probably.
So
anyway, I guess that's why I haven't been making any commits. I've just been like reading papers and trying to think clearly, not very successfully.
Some of these things are hard to think through. They're difficult.
When you talk about features, are you talking about column SDRs?
Yes, pretty much, yeah. Well, and the SDRs and the associated synaptic fields, like they can trace back the receptive fields, which is what people do in, for example, reporting on MNIST data. You can report what are the receptive fields of different neurons, and they'll be representing some sort of small curve in a part of the field, say, and that can then be reused for different types of characters. Whereas you don't want to be learning kind of by rote the whole shape of a character. You want to be learning a kind of reusable bit. So it also touches on boosting. Boosting is like something I've been grappling with since the beginning.
So that opens up. I'm gonna mute. Okay, that opens up the whole opportunity for playing word games, right? Who knows? We still have.
I had one more question, Matt. I don't know if it's the right context, but I saw you send an email about hackathons and possibly joining in an external hackathon. Does that mean you're thinking of not holding a hackathon internally?
So we haven't made that decision yet.
Okay.
I don't know yet. I'm going to be back in the office in a couple weeks, and we're going to have some major discussions about it. I am reaching out right now with Christy, our director of marketing, to see how feasible it would be for us to attach some type of NUPIC component, a technology sponsorship of some kind to existing hackathons around the globe over the next year or two, maybe. It really depends on the response we get. If we get a lukewarm response on that, then I want to have a hackathon. If we get a bunch of interested parties saying yes, you can play a role in our hackathon, come bring your technology, show it to everybody, maybe we won't. It depends, I think, on that. So, hi Chandan, and we also have Dmitry. If you have anything to say, Dmitry, feel free to unmute yourself and join in.
Yes. Hello. Listen
Hello.
again.
I can hear you.
Yeah. Okay. I'm working with electroencephalogy data and near-infrared spectroscopy data. Then I analyze it with a fast Fourier transform, and then send it to learning algorithm, Fourier analysis, electroencephalogy, spectroscopy, and then send rules based on fast Fourier transform into sensory substitution or another device in smart home, Internet of Things. Then these devices working make some work on target condition, which is concentration. So, and then sensory substitution or this actuators then send what they did into a learning algorithm. I will copy some in chat. Somewhere in chat, where is this chat here? Out here is chat. Here is a photo of this scheme.
Got it.
Yeah. Electroencephalogy, near-infrared, rules on FFT, and sensory substitution. Just like in Hawkins' lecture about how our brain works, neocortex works with this data.
Interesting. So I'm showing this right now, so to our audience, so they can see.
Yes. So my trouble in electroencephalogy data is that to make encoder properly encode this data. Now I only looking on what algorithms can do, what encoders I have, and to see what trouble. Now I don't clearly see what is trouble.
Well, so I think this has been a problem. This is an unsolved problem. I think taking any type of this spectrum analysis data or data from a spectrum like an electroencephalogram and reducing it into sparse, a series of sparse distributed representations. We talked about this at the last challenge last fall, when one of our challenges was trying to analyze heartbeats, and we kicked around the idea internally of doing some type of frequency encoder, but I don't think we got very far on that. So there is no answer to this question yet. How do you encode that type of data? I'm not sure.
Yes, I think on next meetup I will say what I get.
Will you be in the Bay Area for our meetup?
What question?
At the next meetup, you mean virtual online meetup?
Yes, I will say in next meetup.
Okay, and feel free to send an update to the mailing list as well. I know there's a lot of people interested in this type of encoding.
Yeah, it'd be really great if there was someone came up with a good sparse FFT encoder or sparse frequency encoder of some form.
Hey, Chandan. You're muted, Chandan. Yep. So Chandan he is organizing our next meetup, which is one of the things I wanted to talk about. Maybe you can talk about it since you're here.
Oh yeah, can you hear me?
Yes.
Okay, great. So let's see. We have right now about 52 people that have signed up, and I guess the location allows for even more people. So I sent out a note this morning, and we have another 10 days to go. So we generally see some RSVPs happen in the last week. So it should be an interesting get-together. This has signs of being much bigger than the last one we did.
Yeah, I think it will be.
And so we had the two talks. Thanks for connecting with Casey and Matt. So Casey will talk about the Graph product. We have one more talk I put up today. It's from, let's see.
Aaron Wright.
Yeah, it's HTM Flink. That would be interesting. And Matt and Jeff Fole have also signed up for a few small demos. So it would be interesting to see all of those. I'm looking forward to it. We also have a slot there from Christy to talk about what's new and what should the community be aware of. So I think she's putting together some content for her slot too.
Thanks, Chandan, for the update. One last thing I wanted to mention is if you're on the mailing list, you know that I was looking for people interested in doing HTM consulting. This is a symbol of growth in our technology in our community, that companies are starting to come to Numenta asking if we can consult for them and create an HTM network or put together a Nupic app or something. And that's not really our business strategy. We don't do consulting. So I went to the community, asked the mailing list if anyone's interested in doing HTM consulting, and put together a list. And I'll be keeping that list up to date. If you have done HTM work in the past with Nupic or HTM Java, even Comportex, if you have experience putting together HTM networks, encoding data, creating applications, let me know. You can email me at matt@numenta.org and send me your basic information, bio, location, and related experience and stuff, and I will add you to this list. So this isn't really an endorsement from Numenta. I'm just collecting people. So, but I am keeping this list to pass to businesses that are looking for HTM consultants, just to let you guys know. One other thing that I think might be interesting for you, Subutai, to mention is you recently went to CoSign. Do you feel like talking briefly about that experience, what you took away from that?
Yeah, so we're in the process of writing up like a detailed blog post on it, so there'll be more detail there, obviously. But we went to a conference called CoSign, which is a computational and systems neuroscience conference. It's the big one every year. And we presented a poster, and Jeff had a talk on it, and we also got to see what everyone else is working on. It's kind of a mixture of theoreticians and experimentalists from the neuroscience world. And it's sort of moderate size, so it's 700 to 1,000 people. So from an algorithms, detailed scientific thing, it was fairly big. From the point of view of a big commercial thing, it wasn't commercial at all. It was small from that standpoint. But it was really interesting. We saw a lot of different experiments and models, and a lot of people trying sensory motor experiments and trying to understand sensory motor behavior, which ties in nicely to stuff that we're interested in. More people are trying sequences and trying to see how sequences and dynamics are modeled in the brain, which is really nice. And I saw a lot of stuff there that was really well predicted by HTM theory. For example, as you learn things and you become more familiar with sequences or more familiar with the tasks, the representations in the brain become much sparser, which is exactly what you predict from temporal memory. And so a lot of people were trying to understand that, like why is it becoming sparser? And so there's a bunch of examples of that particular phenomenon. So it's just stuff like that. It was just really nice to get a feel for what the neuroscience community is thinking about from a computational standpoint and get a view of that. But we'll write up a much more detailed blog post and put it up on Numenta.com.
Thanks, Subutai. Anyone else before we go? We've gotten over our half-hour period for this meeting, so we'll probably close. But I'll open up one more time.
Just okay, one more. So there was this interesting discussion on the mailing list about metabotropic receptors that Jeff joined in, and so the last thing he sent, I guess a couple of weeks ago, was that you'd all had a meeting and you'd come to a really good understanding, and he didn't have time to go into it, but he did give an outline, which is really interesting. But I was just wondering if he's planning, or if someone's planning to expand on that.
Yeah, I know he's been really busy with these talks. He's giving another talk on Tuesdays, and he was in part for part of the conference. I don't think he's had much time to really put his thoughts down and stuff. I know he's kind of rethinking a bunch of things right now. It's probably too early to really talk about it, but he is thinking about hierarchy and sensory-motor behavior and so on. I don't know if he's had much progress in with metabotropic receptors as such, but you never know with Jeff. So I would say just ask again on the mailing list, or I can ask him on Monday if I remember. He's already gone today, but if I remember, I'll ask him on Monday. But just know that he's been really busy traveling the last week and a half, and then next week he's out again to the conference, so it might be a little slow before we start hearing from Jeff again.
Yeah, I mean, it's not urgent, obviously. I'm just curious.
We did see in the at CoSign someone, Professor Barry from Princeton, he tried to teach an animal how to recognize random sequences and would be recording from neurons, and he did see that one, you got to sparse, it learned sequences really fast, like within a few seconds, and you got to see the really sparse responses. But he also saw some evidence of some sort of a pooled response, so a neuron that would become active throughout this whole random sequence. So we were trying to figure out, okay, how could an animal learn that fast with it? So maybe metabotropic receptors are involved in there. We don't know. Yeah. But there was definitely evidence of really fast sequence learning in B1, even very early visual cortex, and evidence of completely a pooled representation of a completely new random sequence. So that was pretty cool to see.
So much we don't know. Okay, so thanks all you guys for joining. On an ending note, I just want to say if anybody's watching and they know of a hackathon they think that Numenta should be at and showing these hackers our technology, trying to get people to use it for their hacks, let me know personally, matt@numenta.org. I would appreciate it. Thank you very much. Take care. See you on the mailing lists.
See y'all.